Lesson 1. Simple and compound interest. Simple interest. When you invest in a financial institution, the institution pays you interest for using your money. When you borrow money from a financial institution, you pay the institution interest. The mathematical formula for calculating simple interest is I equals PRT, where I is the interest, P is the principal, or the amount invested or borrowed, R is the annual or yearly rate of interest, and T is the length of time in years. The mathematical formula is a calculation for simple interest. This interest is not added to the principal and reinvested. In the majority of financial transactions, however, interest is reinvested. In this case, the interest would be added to the principal, and it would be said to be compounded. Note that the time in the formula must be in years. When the length of time is given in months, divide it by 12 to convert it to years, and when the length of time is given in days, we divide it by 365. We'll start with some examples. Example 1. Olive Branch invests $1,500 in a financial institution that offers an interest rate of 4% per year. Calculate the interest Olive will earn at the end of A. 3 years. We use our formula I equals PRT. The principal is $1,500. The rate is 4%, so you notice how we write that out in decimal, 0.04, times 3 for 3 years. If we multiply those three together, we get 180. So she's made $180 in interest in 3 years. For part B, we are going to look after 7 months. So again, we use the formula I equals PRT. Again, the principal is $1,500 and the rate is 0.04. But if you notice, the time is given in months. So if we think of it as the interest made in 7 out of the 12 months, so 7/12 our fraction is. And when we multiply those together, it would be $35. For part C, we want to know what the interest is after 100 days. So the interest is equal to PRT. Again, our principal, $1,500. Our rate is 0.04. We're dealing in days now, and we have 365 days in the year. So our time would be 100 out of 365. When we multiply this out, we get an amount of $16.44. Example 2. Treya Pine invested a certain sum of money in a financial institution and earned $200 interest after 4 years. If the annual interest rate was 5%, what amount did Treya invest? Sometimes when we're dealing with these questions, it's nice to just pull out the numbers that we know. So we know the variables in the equation are I, P, R, and T, and we know that I is the amount she earns in interest, so that would be $200. The rate is 5%, or 0.05. The time is 4 years, and we are looking for the principal. So we go back to our equation. I equals PRT, and we fill in what we know. I is 200. The principal we don't know, so we'll just leave it as P. The rate is 0.05, and the time is 4. Now in order to solve that, we are trying to isolate the P, so we need to get rid of the 0.05 times 4, so we'll divide both sides by that. And we end up with 200 divided by 0.05 times 4. We put in that in our calculator, and we'll get $1,000. So her initial principal would be $1,000. Example 3. Wade Lake deposits $5,000 in an account earning interest at a rate of 4.5% per year. Calculate the number of days Wade must keep the money in for his account to earn an interest of $360. So again, we look at our information that we have in the equation and we write it out. So our interest is $360. Our principal is $5,000. The rate is going to be 0.045, and it's the time that we're looking for. So we start with our equation of I equals PRT, and we plug in what we know. So the interest is $360, the principal $5,000, our rate is 0.045, and it's the t that we're looking for, so we just leave it as t. So now we want to isolate the t, so we need to get rid of the 5,000 and the 0.045 on the left side of the equation. So we're going to divide both sides by those two numbers. So now we have t equals to 360 divided by 5,000 times 0.045. When we put that into our calculator, we get 1.6. Now remember that our t is always in years, so that is actually 1.6 years. And what we're asked for is the number of days. So kind of working backwards from what we did before, instead of dividing by 365, we're going to multiply by 365. So if we take the 1.6 and multiply it by 365, we find that he needs to keep the money in the account for 584 days. We're going to move on now to compound interest. In simple interest, the principal at the beginning of the second year is the same as the principal at the beginning of the first year. The principal doesn't change. In compound interest, the interest earned during the first year is added to the original principal to form a new principal. Let's investigate the difference between simple and compound interest. A bank offers two types of savings bond. A regular savings bond, which pays simple interest at 9% per annum, which is the same as per year, or a compound savings bond, which pays interest at 9% per annum, compounded annually. Considered an initial investment of $15,000 in each bond. For the simple interest, we can calculate the simple interest for each year at 9% to be $1,350. So to complete the table, which gives the value of the bond at the end of each of the first 8 years, we just start with the $15,000 and we keep adding the $1,350. So year 1, we've got the $15,000 plus the $1,350 to give $16,350. We keep adding $1,350 each year. So when we get to the 6th year, we just add on to the $21,750 to get $23,100. In the 7th year, we would have $24,450. And again, we add another $1,350 to that. And at the end of the 8th year, we would have $25,800. Let's now look at compound interest. So complete the following to determine the compound interest and the value of the bond at the end of year 1. So the value of the bond will be the principal plus the interest earned. Principal being $15,000, and the interest earned would be $15,000 times our interest rate of 0.09. Now we could just plug these numbers in our calculator and get a value, and we would get the same value that we got at the end of year 1 for the simple interest. But here, I want to start developing a formula from a pattern that we can get from repeatedly doing this. So instead, I'm going to factor out the $15,000 from each term. So I've got pull out the $15,000, and I am left with, from the first term, I'm just left with 1, and from the second term, I am left with the 0.09. If I add those two together, I have 1.09. So the value of the bond at the end of the first year is $15,000 times 1.09. At the end of year 2, Again, the value of the bond is the principal plus the interest. But now the principal is what the principal is at the end of year 1. So our principal is actually 15,000 times 1.09. Now to figure out our interest, we start with our principal, and then we multiply that by 0.09. Now we have two terms, and the common factors in each of those terms is the 15,000 times 1.09. So I'm now going to pull that out, and I'll have the 15,000 times 1.09, and I'm left with 1 plus 0.09. That just means that we have two 1.09s. So our final answer will be 15,000 times 1.09 to the power of 2. At the end of year 3, again the value of the bond is going to be the principal plus the interest. The principal here is going to be the value of the bond at the end of year 2. So 15,000 times 1.09 squared. Now we're going to add the interest earned, which is going to be the principal, again, times 0.09. Once again, we're going to factor out the common factors, which is 15,000 times 1.09 squared, and we would be left with the 1 plus 0.09. Combine that with the 1.09 squared, and we have 15,000 times 1.09 cubed. Are you starting to see the pattern? Can you guess what the formula would be at the end of year 4?